Many people have asked for this video after watching a couple of previous videos where I have analyzed AI-generated Slop. The question that repeatedly popped up in those videos is this: given an anemic domain model, such as this one, generated by AI or written by a fellow human programmer, what would I, a seasoned human programmer, do to make it better, to make it support a sustainable development in the future? So that's what I will do in this video. I will just refactor this one class. Not a single line of code you see here on the screen will remain at the end. It's so bad. But you will have to see it. Very quickly I will run through the problems again. I'm not going to repeat what I said in the previous video, so please watch my previous videos to see the details why I consider every single line in this class so bad. I will just mention the problems and then we go straight to refactoring and redesigning it. This class is modeling a money transfer, but it exhibits primitive obsession on every property. It also uses an enum to specify state. That is a big red flag already. The data that accompany an enum must be nullable because their existence and meaning depends on the enum value. All these properties are nullable. This wreaks havoc in validation. Properties depend on each other. Some validations are even impossible, so we leave properties in half-baked state. Every property definition warrants a few lines of validation code, which is, by the way, incomplete and often flawed. And then we get to the enum. It makes nullable properties and the combinations of nulls extremely hard to validate. The result is the explosion of states. We try to address that by introducing specific constructors. In this case, constructor overloading cannot help, so we reach out for static factory methods and a private all-encompassing constructor. There will be the whole bunch of static factory methods, one for each enum value. I think this is the last one. 150 lines of code for a class that literally does nothing. Then we get to methods. Thanks to having an enum, every method will look like this. There goes another one, multi-way branching with a mandatory failing branch. Every single method implementation is the source of instability. Nobody is safe from exceptions when calling any method on this class. And there it is, an anemic class with 200 lines of code, and we have barely scratched the surface. Implementation is inflated by a factor of 5 or more and extremely unstable at runtime. That is where this video really begins. I will start from the data definition and do the design from scratch. The bottommost element is the definition of currency. My first reflex is always to define a type. Its name and properties tell the whole story of what the currency is. Property validation is fine, but we acknowledge that the currency cannot truly validate itself. Any random three-letter symbol passes this validation, which is wrong. That tells me that there must be an external validator. Hence I declare an interface that returns a valid currency given an alphabetic code. One concrete variant would represent the entire ISO standard. Another variant could be deployment-specific or company-specific subset of acceptable currencies. That makes a watertight definition of currencies that are always valid. We didn't have that in the original design. Then we defined the money record, which uses the currency as is, knowing that the currency is already valid. That makes all money instances universally valid too. We couldn't even dream about this level of validity in the original design. And with that we have solved this data clump here, which used to cause so much trouble before. Accept the amount, set it, you're done. Zero validation, yet always valid. That is the golden standard. Then we move on to identities of two accounts, which must also be valid. You know the drill. Introduce a type that guarantees that it always contains a non-zero ID. Accept the two instances, set the properties, no validation, yet always valid. Then the datetime primitive type property. This type ensures that all parts of the domain depend on UTC timestamps. Again, just accept an instance and use it. There is nothing additional to validate. That brings us to the enum that used to differentiate the rest of the properties. Why not make everything above this line just an abstract core of the money transfer? The rest is the rest. The enum, the archenemy of class design. It makes every other piece of information nullable. These properties model the process known as 4-eyes approval. Then why there is no 4-eyes approval type in this project? We will come to that. The first measure is to define an employee ID type which guarantees it is a valid GUID to begin with. Then comes the 4-eyes approval abstraction. It does nothing but prepares room for concrete and valid combinations of those employee IDs. An approval may be not required, pending, or approved by just one employee, or approved by 2 employees, or possibly rejected by a single employee. Each variant carries its own combination of values and validates them on its own if required. Each variant also defines the operations it can support unconditionally. A pending approval easily becomes a partly approved one given one employee. It can also become rejected unconditionally. It goes similar with a partly approved transfer. We can easily unify these two states with an interface they both support. An alternate interface indicates a completed approval. The fully approved transfer is of this kind, but also the transfer that requires no approval is of this kind. Do you see how types work for us? There are no nullable properties anymore. There is not a single throw instruction. All operations are unconditional and safe. That part of the model is complete. We don't need any of these properties. All they did was to incur confusion and instability at runtime. I'm deleting them and adding a mandatory approval record to the core properties. And then we address the enum. All it did was to tell that the transfer is one of the several possible kinds. Therefore, make those kinds explicit. There can be a pending transfer, which enforces a pending approval record. Type safety works for us. An approved transfer would require a completed approval on creation. You may think for a moment that this downcast is not safe, but it is. We are operating on a closed set of types. The type system works for us again. A rejected transfer can only be created if there is a proof of rejection. And there is also an expired transfer. The last one we can define is the executed transfer. The prerequisite is to have a completed approval record first. Now you may ask, how on earth do I plan to persist this model? It's very easy. By the way, I constantly get cynical comments on my videos like, good luck persisting this. What can I answer to such comments? I typically say good luck learning about persistence. This is really not an issue. Here's the point. You can persist this model trivially in a document database. You can persist it trivially in a relational database using Dapper. You can persist it using EF-Core because EF-Core supports mappings of all these elements. So all you need to do is to configure EF-Core. That's what it expects. And once you configure the mapping, EF-Core just takes over and does the rest. Scream in the comments and I will make another video about that. But I can assure you it just works. What's more important in this design is that now the compiler will stop me if I tried to create an invalid object. Any call allowed by the compiler in this code is now safe by design. It will never ever fail. You don't have to catch any exceptions. There are no exceptions here. And I will now implement those methods, those two methods, those example methods that I had in the original design, just to show you how safe they are and how safely you can use them. Before I show you that, I will steal a moment of your time to ask you for a favor. This YouTube channel and everything I'm publishing on it is free for everyone, but only thanks to the patrons. So please consider joining the community of patrons on my Patreon page and supporting this channel, because that is the only way for this channel to keep going and producing more free content for everyone. I'm very grateful to every sponsor who is helping me in that endeavor. Thank you very much. Now let's get back to coding, because now I want to get rid of this enum at last, and I want to complete this system of types that provides the complete, safe and stable definition of managed transfer as per the requirements. I will demonstrate how safe these types are by implementing the methods on them. A pending transfer can accept an approval from an employee. As a result, it will construct a new instance. We need an incomplete approval record for that operation. You may think this cast is unsafe again, but it is not. Read the code carefully. Base type holds an abstract approval, but a derived constructor constrains it to this interface. It is safe and done well. Then we analyze what happens when the employee is passed to the existing approval. The catch-all branch is unreachable. You can ignore it. It's there to pacify the compiler. Let me implement execute on the approved transfer. It checks for expiration first. If that's what happened, then return the expired transfer. Otherwise, isolate the completed approval. The constructor signature guarantees it's there, and then use it to create the executed transfer. I told you, all operations are unconditional and they never throw. Why would they throw? Throwing was always the mistake in this model. So let me finally demonstrate how these types work. Your duty is always to create the objects before doing anything. If any of the input data were corrupt, these constructors would fail and you wouldn't have the objects to proceed. That is how type systems work. Then comes the transfer. We would like to notify the transfer that the first employee is fine with it, but transfer type has no add approval method. That is type safety at work. We must isolate the pending transfer first, so to make the compiler happy. There is no failure mode in this code, remember that. We must repeat the process with the second employee. Now we believe that we have done everything by the book and we wish to execute the transfer, but believing is not the same as knowing. We must ensure the runtime type before compiler will let us call the execute method. The good part is that once the compiler lets us make the call will never fail. I will print out the transfer, but be advised that it can be anything. We cannot tell in advance, and that is the beauty of rich domain models. The model itself executes the ultimate control, not our futile and limited try-catch blocks. When I run the demo, the transfer will indeed be in the executed state. But the most striking detail here is that all calls are unconditional and there is not a single try-catch statement. The next step in developing this model is of course persistence. So if you want to see me do the persistence of this rich model, ask for it in the comments and I will do a follow-up video just about persistence. That will be easy. In the meanwhile, remember this. Ditch primitive types and anemic models. Don't let AI resurrect them in your designs. Use rich domain types in your code and you will be happy forever after.